Welcome to Machine Solutions Minutes. My name is Brian Beam, and today we'll be talking about thermal bonding systems and their die heads. We'll be looking at the different types of thermal bonding platforms, the die heads that go with them, the min and max diameters that you can put into these die heads, and how to size them properly for an efficient bonding process. So looking at the different types of bonding platforms that MSI now offers, we have a variety of different types of machines, from very simple R&D machines to much more sophisticated pre-shrink and bond systems. And the reason we have so many different types is that each one performs a specific type of joint. Whether you're doing a butt joint, a lap joint, or a balloon bond, there is a different system specifically tailored for that type of process. That way we don't have one machine that is over-engineered to do all types of processes when you're only going to do one type. From the very simplest 220B, which is more of a R&D development type system to allow you to develop a thermal bonding joint for an eventual upgrade to one of the more sophisticated systems, again, all the way up to, let's say, the 620B, which features a means of pre-shrinking the sleeve before bonding it. Each of these systems, though, uses the same thing: two die heads that will come together and deliver heat to your process. So looking at those die heads, what are the die heads or bonding jaws? These are the two metallic heated dies that will each have a half round bore in them. And when they come together, they will form the die head diameter or the bore diameter that will then encapsulate the parts and deliver the heat to the materials so they can be bonded. So let's go over the important step of how do you size the die head bore. So let's start with the steps involved in determining what that diameter is going to be. So you'll take a coated mandrel, you will assemble your materials over that coated mandrel, and then cover the junction, whether it's a butt joint, a lap joint, or a balloon bond, with a heat shrinkable sleeve such as FEP, PET, or even polyolefin. This is the next most important step. You must pre-shrink that sleeve onto the joint to be bonded. This means that the hot air station must be used to recover that heat shrink material onto your parts, so there's no air gaps between the heat shrink sleeve and your materials. You'll then measure that diameter of the recovered heat shrink sleeve. You take that diameter and subtract 0.003 of an inch, so that what you get is a die bore that is slightly smaller than the OD of that recovered sleeve. You don't want any gaps in between the sleeve and the materials, and you don't want any gaps between the outer sleeve and the die heads. This is crucial for an efficient thermal bond process in which those die heads are going to transfer the heat to the materials. Any gaps, any air, and that bond process will be less efficient. It will still work, but you may have cold spots where those air gaps were. So thank you for attending our Machine Solutions Minutes. We look forward to seeing you again.